So we'll start with capacity planning in this lecture. Now, so in capacity planning, theory may be covered by Madam Yamuna Madam. So we'll directly go for solving the illustrations here. While solving the illustration itself, now and then I may guide the theoretical background also. Can see the theoretical aspects later on. Now, see what are the points are going to be covered here. What are the points are going to be covered here? One is your utilization as well as efficiency ratio of your factory, as well as deciding number of machines required, as well as which machine will be useful or chosen for the different level of demand. Second part. After completion of these two parts, these are the varieties of questions may be expected in capital, capacity planning. One is all about BEP, indifference point, and suitability of machine. This is similar to the indifference point you studied in marginal costing in cost and management, or especially management accounting. Both are same. While teaching the marginal costing, I explained you this particular indifference point will have wider application in OM. So we are going to use the same here also. And second part is all about bottleneck, system efficiency, and increased productivity. These kinds of question will be the second nature. Number of machines required and time required and productivity. So these are the three varieties of questions you can expect in this capacity planning chapter. Right. Before I go for solving those three varieties of questions, let me first finish off this one, calculation of efficiency ratio as well as utilization ratio. Now, design capacity, effective capacity, actual capacity. Design capacity is nothing but maximum capacity that we can produce using the machine is called design capacity. Usually, which is not practically possible. So a day has 24 hours, but will it be possible to work all the 24 hours? Naturally not. In bike or car, the speedometer has a number to the extent of 200 kilometers also in bike. But naturally you cannot go beyond 80 or 100, not safer also. So the design capacity is the maximum capable, but of course we cannot reach the maximum capable. Out of the maximum capable, how much you can reach is called utilization ratio. Out of 24 hours, you are able to work only 8 hours, means 8 by 24. 33.33% of your design capacity could be used. Okay. Effective capacity is nothing but, though your design capacity is 24 hours, of course, you have to take rest and food and other things. You lose around 14 hours a day. Sleep and refreshment as well as food and other things. Sometimes you may be feeling uncomfortable or fever, like you don't work. For that also another 2 hours may go. So balance 8 hours will be called as effective capacity. So out of designed capacity, how much you can effectively usable, no, that is called effective capacity. Out of that, how much you produce is called efficiency ratio. For example, always remember efficiency term is very simple. You have to produce 10 units per hour, 10 units per hour. But if you produce 12 units per hour, what does it mean? You are performing better or efficient. If you are producing only 8 units per hour, then you are called as inefficient. inefficient. Clear? Efficient, inefficient. Hope you will be now able to understand this case. Efficient and inefficient. Efficiency ratio. Utilization ratio as well as efficiency ratio. Given the information below, compute the efficiency and utilization ratio. Efficiency is nothing but out of the time you perform or you are given, what could be the standard output you can produce, but actually how much you produce. If you are able to produce more than what we expected is called efficient. In your examination, 3 hours. In 3 hours, you have to write 100 marks questions. But if you finish up in 2.5 hours, what does it mean? You are more efficient. If you take more than 3 hours, then you are inefficient. You have to improve your efficiency. Within the 3 hours, you have to finish up the 100 marks question. But if you are able to finish up 100 mark question ahead, 3 hours, 3 hours, less than 3 hours, then you are efficient. More than 3 hours, then it is called inefficient. Right. Now, okay. Efficiency as well as utilization. In case of utilization, from the designed capacity, how much you are using? Utilization ratio. The relationship between what? Actual output with design capacity in percentage. In case of efficiency ratio, how will you calculate? Actual output you produced, what is the effective output can be produced? Effective capacity in percentage. Design capacity 50, actual 36 divided by 50, 72%. Here actual being 36, effective being 40. Then this value being 90%. 90%. There is slight difference in this formula. Okay. Actually, what happens, the utilization ratio may be sometimes taken as the relationship between these two. Effective by design. If it is being effective by design, what happens? 40 by 80. 40 by 50. Okay, sorry. Design being 50. 40 by 50 means what is the value? 80%. This approach may also be given. I have seen these two models in the text. Okay. So, what is called effectiveness? What is called efficiency? What is the design? 24 hours is given per day. You are able to work around 10 hours a day. 14 hours you cannot work. Right. In the 10 hours, how many hours you can use? In the 10 hours, how many hours you can work? Probably 8 hours you can work. This is called design capacity. This is actual capacity utilized. This will be effective capacity. Now, if you compare between these two, what is the percentage of effective capacity? Means design capacity could be effective capacity command 10 by 24 into 100. 41.6%. Out of the 10 hours you can effectively work, but you take only 8 hours. Then what does it mean? 80%. Okay. Now in case here for the actual output, you usually multiply this way. Design capacity multiplied with utilization hours, utilized hours multiplied by efficiency ratio. Rather than utilization ratio, it may be utilized hour like I have given here. Design capacity being 24, utilized hour being only 41.67 percentage, efficiency being only 80 percentage. Come on, tell me what's the ultimate value. You'll be getting actual hours of 8 hours, am I right? Round off. Okay, you'll be getting this value. Clear? So two approaches are there. Okay, I too verified in most of the CMA past year's question paper as well as text, and there is a light confusion here. Sometimes the utilization ratio may be this way, or sometimes it may be this way. If nothing stated, you can use this formula. Suppose you are asked to calculate the actual output from design capacity, utilization ratio, and efficiency ratio, then you can use this formula. Clear? Or if you go and refer your same institute material, if you have any clear formula for that, you get back to me, so I'll clarify that later on. Is that okay? This particular content, this particular content. Now, question number 2. A firm operates 6 days a week on a single shift of 8 hours. So, design capacity. How much is that? 6 days of 8 hours each. That's what about the design we have, 48 hours. There are 10 machines of the same capacity in the firm. So you have to multiply with 10 also, 10 machines. Then you are capable of working 480 hours. For every machine, we can work for 48 hours. For the 10 machines, we can work for 480 hours. If the machines are utilized for 75% of the time, how much we are utilizing? Only 75% of available time. So here it is not utilization ratio like utilized hours, like out of 480 hours, how much you are using? Only 75%. So that is called utilized ratio. Utilized ratio 75%. And the system efficiency is 80% only. 80% means any work in 1 hour we supposed to produce 100 units. Because of inefficiency, we could produce only 80 units. 20 units not produced due to the inefficiency. So efficiency ratio. Efficiency ratio, which is 80%. Now what you have to do? You have to multiply all the 3 to get the actual output. Actual output 288. 288 units. Clear? Now, this efficiency, you'll learn all these things in detail along with the standard costing in marginal costing chapter, means in management accounts. So all these things are interlinked. If you're strong with management accounts, almost 30-40% of OIM is over. Clear? Now, question number 1. Come on. Try this illustration. Can you guess? Come on. Guess it. Guess it. See, let me see. A department works on 8-hour shift, 288 days a year, and has the usage data of a machine as given below. So 288 days. Every day we are capable of working 8 hours. Come on, tell me what is the number of hours you have? 2,304 hours you have. Okay. And has the usage data a machine as given below. They need to have 3 products to be manufactured. Annual demand is also there. Process time required for manufacturing A per unit basis. Standard time in hour is given. Then how many hours required for manufacturing A alone? 1,625. B alone? 1,800. C alone? 3,300. What is the total time required? 725. Calculate the processing time required in hours to produce A, B, C. How many hours we are in need? For producing A, B, and C, we are in need of 6,725 hours. Annual production capacity of one machine is in standard hour. Annual production capacity of one machine in standard hours. How many units? What could be the standard hours we can produce for a machine? For a machine, we can produce 2,304 hours. Every day 8 hours, for in a year 288 hours. So roughly using one machine we can work for 2,304 hours. But for producing these 3 machines we are in need of 6,725 hours. Now from this it is very clear, definitely one machine is not sufficient enough. How many machines we need to have? 6,725 hours required for manufacturing all. Using one machine we can produce 2,304 hours of output only. Then come and tell me how many machines? 3 machines. 2.9. Usually you cannot show the value of machine per in fractions. You have to round up to the whole number. 3 machines are in need. Determine the number of machines required. 3 machines. I think the sum is very simple, right? You no need to ask me. In the examination also, some questions will be similarly available, and where by using the logic itself you can solve. Okay. See, in my days, no, OM and operations production management and operations management. Those topics where that subject was in the final, not at the inter level. Just before the examination, I called my friend. What is this all? So guide me. So he guided me about the simulation. And of course, PET and CPM I managed. And I asked him the simulation and all. He guided me. This is the way we have to solve. And I went for the examination. Okay. I spent around 2 days only for learning all these things. And I went for the examination. These kinds of questions, there is no any format, just a normal common sense is more than enough to answer this. By the way, I just answering all those questions, but I didn't have the confidence that I could score good mark or not. But surprisingly, I got exemption in this paper, 68. Okay, a matter of 3 days study. When I started coaching center, this particular paper came to Inter in the name of operations management. Production management is not there, only operations management. I had 3 days lecture. In 3 days lecture, I completed all the portions. Even if you spend 3 days, more than enough to secure minimum pass mark. What about the exemptions, sir? Of course, exemption also possible. Going beyond that requires more additional working, but not required. For the basic 60 marks, you can score better. I think OM is linked with strategic management, right? So OM is how much? 60 marks. 60 marks, you can guarantee score 30 marks without studying further. 30 to 35, just 1 day glance is more than enough to score. So for scoring good mark and clearing the CMA Group 2 in single shot, you need to put more efforts on management accounting. Next will be corporate accounting. This chapter is very simple. See, next one, we'll see. Come on, try this. Calculate the number of machines required to produce three components from the information given below. We have to manufacture three components. One small extra information I have to share, then you will be able to understand this easily. What is that? Setup time and operating time. So you have to understand the difference between these two. Of course, these two also you can guess casually by learning the batch costing in management, means cost accounting. We will study that along with the costing chapter. Of course, material costing, batch costing. These two chapters are not for management accounting, but that particular two chapters, material costing as well as batch costing will be common for CMA Group 1 costing, CA Group 2 cost and management accounts, in CMA Group 2 financial management, working capital management, and then jump to here, OM. It will have the wider applications. Once you understand that, it will be used for all the places. Right. Ready options for any requirement, you can use this topic. Here, batch. A batch. When you plan to produce items in batch, at a stage you produce 100 units. So what happens? I am giving the classes for 100 students at a stage. If anybody joins in the halfway through, they will not get the understanding. It's not one by one. But in case of doctor, he treats every patient independently, right? He will not call for all the patients to sit in an auditorium and guides, open your eyes, drop this medicine in your eye and operate yourself. No, it's not possible. So there, the doctor has to inspect each and every patient independently, spends time for each and every patient independently. That one is called job costing. At a stage producing 100 units, 50 units is called batch costing. Suppose in case of job costing, process costing, like, right? See, you have to set the machine. In the morning you come and set the machine. Once machine is set, okay, set up the machine. Once the machine is set up, thereafter you start production. But setting up time will also be there, right? It's usually having no production. Once the machine is set up, it may be capable of producing 100 units or 500 units like. Thereafter, you have to change the setup. Every time you have to change the setup to produce fresh. Is that clear? So always remember, time requirement will be calculated for any product manufactured based on the setup time also. Once you set up, thereafter you can produce 100 units, means first you calculate the setup time, that is also be taken. 100 units are manufactured, that is called operation time, that should also be taken. That's all. Rest of the things are same. Right. Now let me see the production of component A. Setup time per batch 25 minutes. Before we start the fresh batch, we need to have 25 minutes to arrange all the machines. Once we arranged, then we can start manufacturing. For that 25 minutes is over. Thereafter, I can manufacture. How many units I can manufacture? Batch size in units being 350. Once the batch is set or machine is set up, I can manufacture non-stop 350 units. Thereafter, again I have to change the setup. No way. Now, for producing every piece, I need 1.75 minutes. What is the demand? Production per month expected? 2,450. Now come on, tell me what is the time required for manufacturing A? Let's start with the first one. Time required. Time required for component A. You have to start with what? Setup time. How much you spend time for setup? 2440. And per batch, how many units can be manufactured? 350 units. So to produce 2450 units, how many batches I have to conduct? 7 batches. In this classroom, I can conduct the classes for 50 students. If I get admission for 300 students, how can I conduct the classes? I need to have 6 batches. Okay, the same happens here. I'm in need of 2450 units to be produced. For every batch, I can produce 350 units. For setting that first batch, it requires 25 minutes for every batch. So I may lose 25 minutes. So if I multiply with 25 minutes, what's the time required in terms of minutes? 175 minutes for setup alone. Apart from that, what about the operation time? Units produced, 2750 units, 450 units are produced. For every unit, I'm in need of 1.75 hours. So 1.75 minutes. Come on, tell me, what's the total minutes required? 4287.5. What's the total time required for A? 4462.5. Similarly, calculate for B and C. First question very basic. In this question, you learn only one thing extra, which is nothing but setup time. You have to find out what is the total time you spend for the setup alone. Thereafter, production. So production is 1.75 into number of units produced. There is no any confusions for setup. Number of setups you have to do for producing the required items here. For that, requirement in units divided by units produced per setup will be considered here. Right. Similarly for B. Come on. Setup time. 4400 units are in need. For every time I produce 550 units, once setup is made, for setup I need to spend 55 minutes. What is the time required for setup alone? 440. Apart from that, production time is there, which is nothing but operation time. 4400 units to be produced. For every unit I need 3 minutes. 13,200. Overall time being 13,640. Now for C, we'll start with setup time 2875. How many minutes, how many units can be produced for every setup? 575. What is the time spent for every setup? 45. What is the total value? 225. And operation time 2875 divided by multiplied by, what is the time required? 2.1 minute. 660 or 660? 6037.5. What is the total value? 6222, huh? Okay. 62. Okay, 6262. Okay. 0.5. Okay. Assume a month consisted of 25 days and 8 months, 8 hours. Come on. What's the hours you have? 200 hours into 60 minutes. 12,000 minutes you have. 12,000 minutes you have. Am I right? You have all the details in my minutes, so you have to convert that into the minutes. Come on. Find out the total time required. Yes. Add up the 3. 24,365. Okay. Now, machine efficiency is only 85%, operator efficiency is only 75%. In a month, you can, the design capacity being 12,000 minutes. I am in need of 24,365 effective production minutes. But all the 12,000 is not production minutes, right? We lose due to the machine's inefficiency, operator inefficiency. Okay, sometimes calculator is not working. Because of that, you delayed 2 or 3 minutes for solving one problem. This is called machine inefficiency. You don't have the practice to calculate, then it is operator inefficiency. So you have to improve both before you go for the examination. Do you have the perfect calculator? Huh? You have the perfect calculator. So I have this calculator now here. When I press 4 or 5 numbers faster, the number will go out. Okay, so it takes lots of time. Okay, so you have to play with that number also. Machine efficiency also matters, operator efficiency also matters. Okay, machine may be the superb machine, but the operator is not capable of using that. Also, then waste only. Here, due to 2 reasons, the 12,000 minutes we have for the design capacity could not be used properly. Now, this is what about the design capacity and machine efficiency, only 85%. Operator efficiency, 75%. Come on, multiply all the 3 to find out the productive minutes available. Productive minutes, 7,650. Okay. Now, number of machines required. Machines required. What's the time required for producing? Time required for output supposed to be produced. Time, productive time available. What's that? Productive time available. Available per month. The time required being 24,365. Though we have 12,000 minutes, but is it 7,000? 650. Okay, 7,650. Okay. 7,650 is the productive minutes available. Come on, tell me the number of machines. 3.18. Anyhow, you have to round off to the whole number, 4 machines. Clear? Shall I move on to the next one? So the next one also similar, but we have 3 machines. Here 1 machine, we have 3 machines. The next illustration. So we have to find out number of machines for requirement for each and every category of machines. Shall I go for that? Okay. Now, 3 components are to be manufactured on 3 machines. That is center lathe, milling machine, cylindrical grinding machine. So 3 machines we need. We have 3 machines: center lathe, milling machines, cylindrical grinding. And we need to manufacture 3 components: component A, component B, component C. Now, how many center lathe I am in need? Center lathe is required for manufacturing component A, component B, component C. How many units? 1,750 units of component A. Earlier case, you just skip this. This was the earlier illustration. Here we don't have not only central lathe, we have the another two machines also, milling machines as well as cylindrical grinding. If we calculate the number of central lathe is required for manufacturing component A, component B, component C using central lathe, we have to calculate separately. Similarly, repeat that same for the milling machine as well as grinding machine. Is that clear? So, let's see. Calculate the number of machines required of each kind to produce the components if the plant works 48 hours per week. Month consists of 4 weeks. Okay. Then 48 hours into 4 weeks. 192 hours. If the hours missing per month basis, always keep the numbers a standard number in your mind. Day consisted of 8 hours. Week maybe 5 working days or 40 hours. Month will be considered as 4 weeks if nothing stated, or 4 into 5 months, like 5 into 40, 200 hours also can be taken. Sometimes it may be taken as 180 hours, means 4.5 weeks per month into 40. Whatever the assumption you do know, you can give a small hint. It should be a logical assumption. In this illustration, it is clearly stated a week consisted of 192 weeks, 192 hours, sorry, 192 hours. Now come on, number of center lathe requirement. Center lathe. Let's start with center lathe here. Now, center lathe for component A. For component A, setup 30 minutes. Number of setups being, how do I calculate? Okay, demand by lot size. Lot size is nothing but batch size into setup time plus operation time into number of units, or demand into number of units. Demand into number of units means operating time. That's how we can get the answer. For A, demand being 1750 units, lot size being 350, okay, into setup time being 30 minutes. And what about the operation time? 1750 into 2 minutes. What's the total value? 3650. In case of B, 4000 by 400, 10 setups per setup takes 55 minutes, and 4000 units produced. For every unit we need to spend 2.5 minutes. Now what's the value? 10,550. Similarly, go for C. 3000 divided by 600 into setup time being 40 plus 3000 units multiplied by 1.5 per unit. 2000, 4700. What is the total time requirement? 8900 minutes. 18900. Now you can convert. See, either you can convert everything into minute or hours. So I will convert this into minute. Come on, tell me the minutes. 192 into 60. 11,520. 11,520. Now number of machines required. Center lathe required. How do you calculate? 18,900 divided by number of hours, minutes available, 11,520. Come on. 1.64, otherwise 1.64, otherwise 2 machines. Now, calculate the number of machines required assuming the machine's efficiency is only 75%. If the machine efficiency is only 75%, then what could be the number of machines? As the efficiency is decreasing, you need more machines. Time waster is there. So we cannot finish up in two machine itself. Then 11,520 minus efficiency. Okay, productive R. Productive R, but here it's productive minutes. You have to multiply 11,520 design capacity with that 75%. Come on, tell me. 8,640. So, if there is 75% efficiency, the answer being 18,900 required, but the productive capacity being 8,640 only. Come on, tell me the answer. 2.18. Otherwise, we are in need of 3 machines. Or you can calculate this way also. 1.64, you get this? No. Divide that by efficiency. 1.64 divided by efficiency being 75%. You will get the same answer. Rather, you can calculate the productive minutes available and then you proceed, or calculate as per the regular one without considering the productive means inefficiency as well as misutilization and all. Thereafter, divide that by the underutilized value. So then you will get the same answer. This is also equal to 3. Clear? Now, the third question, how do you reduce the number of machines? So, we are in need of 2.18 minutes. You can now recommend. Can you improve the machine efficiency, sir, by doing some additional overhauling and repair? If it is so, we can increase the 75% efficiency to 80%, like, then automatically we can reach. Or ask the employees to work in overtime. Okay, one shift. So, you can have now and then some overtime so that you can manage with the 2 machines. You have to recommend. Of course, currently we are in need of 3 machines. If you recommend 3 machines are needed to the management immediately asks the question, we need to invest so much. Is there any chance to manage with the 2 machines? Yes, sir, manageable. By purchasing 1 extra machine, it costs me 1 lakh extra. But if I extend the working hours as overtime, I have to pay extra money. The extra money may be 70 or 80,000 rupees. Compare these two. By asking the employee work higher means overtime, employee is also happy with another 80,000 rupees, and management is also happy because of investing in new machine. They can simply spend the cost for new machines to the overtime payment. Very simple. You can give the solution. So I have completed the machines requirement for center lathe. You can calculate for the milling machine as well as cylindrical grinding yourself. Come on, try. Milling machine you can try. Make it fast. In Singar Academy text, I converted that into hours and applied the second method, this method. Okay, solution. Also be accepted. So you can try for milling as well as cylindrical grinding. Anyhow, I may also solve this. but you can also join with me to solve this. Okay. In case of a milling machine, okay, for manufacturing component A, setup time being 1750 units to be manufactured. Every setup will capable of producing 350 units. For setup, I need to spend 45 minutes, and number of units produced being 1750 divided by 8 minutes. Sorry, into 8 minutes. Come on, tell me. 14,225. In case of B, 4,000 units to be produced, but every setup will help me to get 400 units completed, and every setup requires 30 minutes, and 4,000 units into 4 minutes per unit. What's the final value? 16,300. Of course, we no need to use milling machine for producing component C. Only these two components are produced. Overall value being 30,525. And how many machines are in need? So every machine capable of working for 11,520 without any inefficiency. With inefficiency, it will work only for 8,640. So 30,525 divided by productive hour available in this case being 8,640. Come on, find out the number of machines, number of milling machines required. 3.5, round up to the next higher number. Round up to the next higher number. Similarly, try for the component C. Means cylindrical grinding. Let me go for the cylindrical grinding. Okay, cylindrical grinding. Now we'll start with component A. 1750 divided by 350 multiplied with the setup time, in this case being 50 minutes. Operation time being 1750 into every unit requires 8 minutes. Yes, 14,250. For B, 4,000 units to be produced. Every setup produces 400 units. Setup time being 60 minutes, and 4,000 units requires 8 minutes per unit for the operation or production. Overall minutes requirement being 32,600. For C, 3,000 divided by 600 into setup time, in this case being 60 minutes, plus 3,000 into 10 minutes. What's the value? 30,300. So overall value being 77,150. Now what is the number of machines required? So productive hour available being, minutes available being only 8,640. Then whole number being 9. Whole number being 9. So you can give the suggestion this way. How can we minimize? Working 2 to 3 shifts, like you can minimize the number of machines requirement, or increase the utilization with this proper maintenance also. Is that clear? Hope now you will be able to understand how to answer this question. Clear? Come on, make a note of it. So let me finish up this. A furnace wants to expand the solid propellant manufacturing plant, adding the required number 1 ton capacity curing furnace. So design capacity being 1 ton. Each ton of propellant must undergo 30 minutes of furnace time, including loading, unloading operations, everything put together. So for 1 ton production, we need half an hour, otherwise 30 minutes, 0.5 hours. Okay. Furnace is used only 80% of the time due to the power restrictions. So how much is used? Only 0.8. This is what about the utilization. And the required output for the new layout is to be 16 tons per shift of 8 hours. So now what about the output required? Output required being 16 tons. Otherwise, output required meant rather than in tons, if you represent that in terms of hours, it is 8 hours. It is 8 hours. Either you can use in ton or in hours. You are in need of 8 hours productive hours or 16 ton to be produced. It's not actual designed capacity, it's actual productive hours. Plant efficiency is only 50%. In this case, efficiency is only 50%. Now, what about the productive hours? Productive hour, come on, tell me. You have to multiply all these things to find out the productive hour. Yeah. A day consisted of 8 hours also. You multiply all these things. 8 into 0.5. I just remove this. You can take this. 8 hours available. You utilize only 80%. Efficiency only 50%. What is the ultimate value? 3.2. So 8 hours divided by 3.2. The final answer being 2.5. Otherwise, how many machines are in need? 3 furnaces in need. 3 furnaces in need. Okay. 3 furnaces. Estimate the percentage of time the furnace will be idle. Okay. 3 furnaces, 8 hours a day. So 24 is the capacity, design capacity. What is the time required? Okay. What is the time required?
8 hours.
8 hours only. This is design capacity and time required being 8 hours. So how much time you are keeping idle? 16 hours. This is called idle time. So 16 by 24 in percentage, almost 66.67% remains idle. Remains idle. Clear? Now, the most important content, I classified all the items into 3 varieties here. BEP, bottleneck, calculation of number of machines required, time required, and productivity. The last one already completed. Similar illustration will be covered in the last also. So let's start with the first one, BEP, indifference point and suitable machine. Okay. Let's first start with the BEP, break-even point, and draw break-even point chart, etc. This one we already studied along with the marginal costing chapter. So you can easily understand this one. So BEP is nothing but what? Fixed cost divided by contribution. Fixed cost in this case being 1000. And contribution is nothing but the difference between sales and variable cost is the contribution, which is 2 rupees. So 500 units will be BEP in units. To represent BEP in rupees, you have to multiply the 500 with sale price being 4. So 2000 will be the BEP in rupees. Also, you have been asked to draw the break-even point chart. For the break-even point chart, what you have to do? You have to find out the total cost, fixed cost, variable cost, total cost, and total revenue. You draw the table here and then plot that in the graph for various level of production. So you know that 500 units being the break-even point, you can start this way: 200, 400 units, 600 units, okay, 600 units, 800 units. Better you can have in between also 500 units. In between also 500 units. Fixed cost being 1000 remains constant at all level, isn't it? This number you can decide yourself. Okay, the range could be something less than BEP, something more than BEP. Like 500 is a BEP, no? So reduce some number lesser, 400, 300, 200, or 200, 400, like. Above that, 600, 700, 800, like you can show. So there is no any hard and fast rule. And variable cost being 2 rupees per unit for the number of units, you have to multiply with the 2. So the value in this case being 400, 800, 1000, 1200, 1600. The total cost in this case being 1400, 1800, 2000, 2200, 2600. And total revenue here being 4 rupees per unit. So you multiply this with 4. So 200 into 4, 800 and 1600, 2000 and 2400, 2800. You know that 500 units is a break-even point where the total cost is equal to total revenue. You plot this data in the graph and draw the chart for the BEP. I skip the BEP diagram here. You can understand this diagram easily. Otherwise, you go and refer the marginal costing. Clear? I don't want to reteach this here. So let's move on to the next illustration. Come on. An item is produced in a plant having fixed cost 6,000 per month, variable cost 2, selling price 7. Find out the break-even point. So break-even volume is very simple, right? Come on, write the answer along with me. BEP is equal to fixed cost divided by contribution. Contribution is equal to 5 rupees, sales minus variable cost. So fixed cost in this case being 6,000. So 6,000 divided by 5, 1,200 units. Okay. And even you can represent that in terms of rupees also. BEP in rupees is equal to, you have to multiply this with selling price. The selling price in this case being 7. So 8,400 will be the BEP in rupees. 8,400 will be the BEP in rupees. Clear? Now, if 1,000 units are produced and sold in a month, what would be the profit? So you have to find out the profit here. For the calculation of profit, profit is equal to sales into PVR, or what you can do, sales unit into contribution per unit. This is what about the total contribution minus fixed cost. So sales being 1,000 units, for selling every unit you get 5 rupees being the contribution, and 5,000 will be the total contribution. Your fixed cost 6,000 should be subtracted, so you are actually facing loss. So as you know that 1,200 will be BEP. So your break-even level is 1,200, means selling less than that will be definitely loss making only. So here 1,000 units, definitely there should be loss. So we find the loss being 1,000 rupees. Finally, how many units should be produced to earn 4,000 rupees? This is what about the desired profit case. In case of desired profit case, what is the formula? Fixed cost plus fixed desired profit. Don't study this chapter without studying the marginal costing chapter. Finish up marginal costing and come here. This is very simple. Okay. Fixed cost plus fixed desired profit divided by contribution per unit. So fixed cost 6,000 and fixed desired profit we estimated here being 4,000, and contribution per unit already we found out, which is 5 rupees. 2,000 units. Same you can represent in terms of rupees, which is 2,000 into 7 rupees, 14,000 in rupees. Okay. Hope now you'll be able to understand. This is very simple illustration. This illustration given in the text, so I am solving. Otherwise, you no need to study this at all. Clear? Shall I move on to the next one? Online students, come and respond me. We will move on to the next one. Make it faster. Now, we'll go for the third one. A manager has to decide about the number of machines to be purchased. He has three options, that is purchase one or two or three machines. The data given below: variable cost 40, variable cost 20, revenue 40, contribution should be 20. Am I right? Sales minus variable cost is equal to contribution. Determine the break-even point. Break-even point in each range. So break-even point in units is equal to fixed cost divided by contribution per unit. Here fixed cost being 10,000 rupees divided by 20 being 500 units. Here 12,000 divided by 20, 600 units. Here 20,000 by 20, 1,000 units. We got the answer here. Clear? Clear? If you purchase one machine, you can produce and sell in the range between 0 to 400 units. If you purchase two machines, you can produce and sell in the range between 400 to 700 units. If you produce 300 units, install 303 machines, you can produce anywhere between 700 to 1000. Clear? Now come on, tell me, what do you understand from here? If you install one machine, 500 will be your BEP, but your maximum capacity is only 400. Most of the cases, the business people will lose their profit or their investment only due to this reason. Okay. What happens? 10 by 10 size small business. They start with small, probably investing with a printer, probably Xerox machine. One Xerox machine is capable of producing maximum 400 units. Usually what we'll think? We'll start with small. We start with small. Don't go for bigger business. You'll lose your money. But the trouble is, if I start with one machine, so all the people will suggest go for one machine. If it gets picked up, go for second machine. If it is still picked up, go for third machine. This is what about the normal suggestion idea of most of the investors. If they start with one machine, maximum capable production being only 400 units, but you can attain the break even only at 500 units. By running with one machine, you never face gain. You definitely collapse and you close the business. Are you able to understand? This is the logic. Most of my friends come for a suggestion. I am starting this business. What could be my investment? Don't compromise in investment regarding these kinds of requirement. 100% investment will give you 200% return. If you don't invest 100% investment, you will be getting 50% loss. 100% investment means for that particular shop, you need to have at least two machines. If you have at least two machines, your production may go up to 700, where 600 will be a BEP. Beyond that, you will be making nice gain. If you have three machines, also be not advisable, because your market demand is only 1000. Your break-even point by installing three machines also 1000. So if you are working 100% capacity, you will just then break even. You don't get even single paisa in your pocket. So not advisable to have one machine installed. Not advisable to have three machines also in your business. If projected demand is between 600 to 750 units, how many machines should be the manager purchase? By purchasing one machine, it's not advisable and foolish decision. Purchasing three machines also, you get BEP only at 1000 units of production. But here what happens? Only 750 is market demand. Though you produce 1000 for your break even, there is no options to sell. You are actually losing the business. Here also you are losing the business. Here also you are losing the business. Only this one will be good business. Okay, I did lots of business in my age. Okay, immediately after the colleges, I joined with my friends and did lots of business. And most of the business ended with the loss only because of this reason. We now compromise spending. If the project requires 1 lakh rupees, I think I have 50,000 rupees, balance 50,000 I can manage. How can you manage? I started and invested 50,000 rupees, but the need arises for 1 lakh rupees of investment, but I don't have the cash. So managing somehow will not be really working. Sometimes later the entire 50,000 also be lost. So then I made a decision. Sometimes later, if I need to invest 1 lakh rupees for a project, I need to invest 1 lakh rupees, have at least 50,000 rupees as a means contingency reserve, so that I don't face any loss. The moment I decide in that way, then I don't face any loss. This is a part of operations management and marginal costing. Optimum machines to be purchased. Optimum machines to be purchased. Is that clear? Hope now you'll be able to understand the third one. Shall I move on to the next one? Now, we'll go for the next set of problems. Bottleneck. Bottleneck problems. Come on, tell me. Tell me. Try to answer this. Don't read the answer, just guess the answer first. Online students, come on, keep responding. Yeah, tell me. Can you guess? Any guess? Huh? What is called bottleneck? Thin place. Okay, see, if you are going by road, what is a bottleneck? Usually the bridge. The size is very narrow, you cannot cross there, and all the traffic will be there only. The capable of moving in that road will be equal to the capacity of the bottleneck only. Though you have full drinks in the bottle, if you are transferring, means if you are moving, making it upside down, it will not fall immediately, slowly, because bottleneck. Come on, tell me, what is the bottleneck here? If I put the raw material as input 450, A will process 450 units, B will process 360 units, C will process 340, D will process 400. Come on, tell me, what is the bottleneck? That's all. C is the bottleneck. So, A can capable of producing 450. Otherwise, you think the road this way. And thereafter narrows. Thereafter still narrows. Thereafter it will be this way. Now, how many vehicles can go? Here 450 vehicles, 360 vehicles, 340 vehicles, 400 vehicles. So though here 450, anyhow here will be cramped. Only 340 capable of releasing every hour. Once it comes out, then relax will be there. Okay, free. Traffic reduced. Is that okay? So what happens here? All the people will come here, narrow down. The difference between these two, 90 will stuck to travel here. Those moving from the straight line can move, but here they will stuck. They will stuck. Here 360 will be moving, and in this case only 340 is capable. Another 20 will get stuck. Another 20 will get stuck. After that, what happens? This particular place capable of storing or managing 400 crore, but only 340 comes out. That's the logic. Now, what about the capacity of this particular road? Only 340. Though you are able to travel 450 here, because of this reason, we cannot travel more than 340 passengers. Rather than passenger, you can convert that into the products. That's all. Now you'll be able to understand easily. Come on, tell me. A firm has 4 work centers A, B, C, and D in series with individual capacities. A's capacity, these are the work centers. A work center, B work center, C work center, D work. 4 factories are there. The product introduced as input in the first factory will pass on to one after one and will come as an output at the 4th workshop. So A is capable of producing 450, but B can produce only 360. The difference between 90 structs here, otherwise stockpiles. Okay, 450 came, but B can process 360, 90 remains in outstanding, means in queue. And here 340 can produce and 20 remains in stock. What about D? They can capable of producing 400, but only 340 comes as input. 60 stock out. They are ready to process another 60, but there is a stock out. Now bottleneck being B, C. Apart from that, what is the system capacity, sir? System capacity is equal to the capacity of C only, which is 340. How many units can be produced? Okay, 340 only capable can be produced here. Though A can produce more, B can produce more, but C cannot. Unless we get it completed in all the workshops, it will not be output. It will not be output. Hope you will be now able to understand 340. What is the system efficiency? System efficiency. 340 is the expected one. This is the capacity. What is the output we actually get? So 300 only we are getting out of 340. Then come on, tell me what is the efficiency here? 88. Okay, percentage. Very simple. Very simple, right? This question carried 6 marks in the very first time in the examination. Sometimes 8 marks also. See, all these things are to make you pass. Come and become cost accountant as soon as possible. That's how they are inviting because of this question. Try the next illustration. Hereafter you can try it yourself. First to see the meaning, bottleneck. Then you can solve the other things easily. Make it faster, make it faster. Yes. Online students, come and text me. Make it faster. A customer is processed through each of the 3 operations A, B, C in sequence. So, if you go to any interview, right, or in banking earlier, first you have to give the challan and you have to wait for collecting the cash, and then after collecting the cash, you need to wait for getting the passbook updated. Earlier, now everything is online. If you go to interview, first written exams and then oral and then group discussion, 3 processes. So we have 3 processes A, B, C. The process is designed to handle 100 customers a day. The average rate per hour at which each operations can process customers is shown in the figure below. Per hour, A can handle 15 customers, B can handle only 10 customers, C can handle 12 customers. 15 customers are verified and finished, and they will go out from A. And in B, they can manage only 10 customers, 5 customers should be in queue. And C, they are capable of handling 12 customers, but only 10 customers are coming. They are having free time, idle time for 2 customers. Okay. For an 8 hours day, identify the bottleneck. What is a bottleneck for 8 hours? 1 hour 15 minutes, 8 hours. How many customers can be handled by A? 120, B, 80, C, 96. Okay. And what is the bottleneck here? B is the bottleneck, which is capable of producing only or managing only 80 customers. What effect will the bottleneck have on overall output? What effect? Only the output to processed by B will be the output at all. Okay, that will be the final output. That will be the final output. If all the processes are operated for 10 hours per day, is there still bottleneck? Yeah, of course. If 10 hours working, then this becomes 150, this becomes 100, this becomes 120, still B will be the bottleneck. For this question, 8 marks was there earlier in the exams. Right. Let's move on to the next question. Now tell me, find out the bottleneck. So one of the interesting illustrations, so I wanted to include that, so I included the last batch only. Come on, guess. Now, find out the bottleneck process and system capacity. Process A and process B are parallel. Process C has to handle the output from process A as well as process B. Now, what could be the input from A and B for C? 30 plus 40, 70. These are parallel. C can handle only 60, D can handle 80. So, process A and B capable of producing combinedly 70, where process C has to handle the output of A as well as B, but they are capable for only 60. Then this is the bottleneck, and system capacity also 60. Clear? Let's now move on to the last illustration on this chapter. A department of a company has to process a large number of components per month. The process equipment time required being 36 minutes per component, whereas the requirement of an imported process chemical is 1.2 liters per component. The manual skilled laborer required being 12 minutes per component. So they are in need of 3 items. One is process equipment, next one is all about chemical, third one is manpower. They are in need of 3 different inputs. Now, what is the equipment hours they have? 500 hours, efficiency being only 85%. Okay, what about the time required? 36 minutes. So, into 60 by 36. This will be the output. So, you have to find out the output here. 500 hours available, but it is efficient for only 85%. 85%. Clear? But for producing one item, 36 minutes required. This is in terms of hours, so I convert that in terms of minutes. This is what about the total minutes available for the production purpose, and for producing the output, we are in need of 36 minutes only. You divide that by 36. What is the output? 708. In case of imported chemical, 1000 liters available, 5% may be lost, only 95% can be usable. And for manufacturing this component, we are in need of 1.2 liters every time. 1.2 liters every time. Divide that by 1.2. Come on, tell me the value. 792. 792. Skilled manpower 250, 65 percentage will be effectively used, and the requirement of skilled manpower for this component being only 12 minutes. So 250 into 65 percentage will be the number of skilled manpower available, but to convert that into minutes I multiply with 60 and then divide the time required for manufacturing this component, which is 12 minutes. Come on, what's the value? 830. So for the production, we are in need of equipment, chemical, skilled manpower. Using the available skilled equipment, we can manufacture 708, but chemical, we can manufacture 792 units. Using the skilled manpower, we can manufacture 813. Then come on, tell me, which is the bottleneck? Equipment is the bottleneck. This is the bottleneck. Okay. Then the system capacity should be equal to only 708. System capacity also 708. What is the maximum possible production under the current condition? What is the maximum number of units can be produced here? 708 only. Clear? You can produce only 708. The next question, if skilled manpower availability is increased by overtime 20 minutes, 20%, what will be the impact? If you are rising by another 20% by making the employees work in overtime, what will be the situation? Situation will be the same, because that is not the bottleneck. To improve the efficiency, what you have to do? You have to break the bottleneck. By increasing 20%, 813 plus 20%, how much units could be produced? 976. Though we produce 976 components using the skilled manpower, but equipment hours not available, still the bottleneck being the same equipment hours. So you have to raise the productivity of the equipment hours to improve the output. Clear? Hope now you will be able to understand. Now we will be dealing with location and layout. Okay. So location is nothing but selection of place where to start your business. Layout is nothing but the facilities to be installed within your selected location. Is that okay? For example, okay, in this place, you have 4 options, A, B, C, D. 4 options we have chosen, where raw material is available here and finished goods saleable at this place. Laborers are available here. Investors are available here. Now what happens? Among the 4 locations, which location will be suitable for you to start the business? D. Logically, this may be closer to all the resources available. So D is chosen. This is called selection of location. Selection of location. Once you have chosen D being the most suitable location, now the next question is where to have front office, where to have the office, MD room, factory 1, factory 2, factory 3, like setting this one, the facilities installation within the factory chosen or place chosen will be called facility layout. So we have to study these two, facility layout as well as location. The way how we have chosen here is called center of gravity model. Okay, this D is very center for all the resources required for the starting business. So based on that center, if you choose, then it is called center of gravity model. The other models also available here. Let's start with, okay. Question number 1, factor rating method, non-weight, okay, non-weighted method. A new medical facility, health care is to be located in Delhi. They plan to construct a hospital in Delhi. Where we want to construct this? That's the question. The location factors rating scores for 2 potential sites are shown in the following table. So factor rating and rating for the location 1 and location 2. Location 1, okay, location 1, facility utilization being having a rating of 3. Having the rating of 3. Now come on, tell me, if you want to start the medical facility, where do you want to start? Okay, where do you want to start? Huh? Where to start is better? Come on, tell me. In general. Hospital should be nearby where? Nearby Pizza Hut. Or fast food. If there is a fast food, definitely the closer we need to have the hospital like. Is that okay? So where the patients are more, you need to start the hospital. Not only patients are more, they are capable of spending or they demand only GH. Not only spending capacity, if anything happens worst, immediately we have to transport them. So ambulance facilities as well as transport facilities, all these things are in need. So for facility utilization, how effectively you are using this? Total patients per month. And in case of emergency trip, using the ambulance, how quick we can transport. And the cost we spend for constructing the hospital, land and construction cost. And whether the doctors are coming here or not. Employee preferences. Employee preferences. If we want to start an eye hospital in Rameshwaram, what happens then? We don't have the sufficient doctors there. So we have to bring the doctors from north side or some other metro to there. So then they will demand more salary. Sir, we don't want to come to a village like this place or down south in Tamil Nadu. We don't prefer. So doctor's choice also be matter. Now among these 5, which is the most important? Which is the most important? Patients. All the infrastructure built, but if you don't have the patient, then you cannot run the medical hospital. Okay. So from this, it is very clear. Utilizing the entire resources you are installed will be the main factor. You give almost 8 points for that. Patients 5 points. Emergency trip, ambulance arranged. That will be the predominant one. So we give around 6%, 6 times importance for that. And land construction cost is not a matter. So we can get the money from various investors anywhere, no problem. So only 3. It's the least criteria. Money is the least criteria, which is the most important criteria. If I install the hospital, it should be utilized properly. Sir, that will be the my most criteria. 8 points will be given. And the employee preference also be given 5 shares. This is what about my criteria for starting my medical hospital or a hospital. I just now shortlisted 2 locations, location 1 and location 2. If I go for the location 1, with respect to the facility utilization, only 3 will be the possibility. 3 rates is there. But if I choose location 2, I may have 5 share, 5 points. Then what happens in case of location 1? You multiply the factor rating and locations rating. 3 into 8, 24 will be the rate we have, weighted rate you have for location 1. In case of location 2, 8 into 5, 40 will be the value. And here 5 into 4, 20, 5 into 3, 15, 6 into 4, 24, and 6 into 5, 30, 3 into 1, 3, 3 into 2, 6, 5 into 5, 25, 5 into 3, 15. Now total this, come on. $95, $96. Huh? 106, 96. Which is chosen? Naturally, you can go for location 2. Clear? This is called factor rating method, non-weighted. Instead of using the rates absolutely, we may sometimes use the weights also. That's the second one. Come on. Second one, factor rating method, where I am going to use the weight. A media company proposes to build new office in one of the 3 locations. So they have chosen 3 locations. Using the data below, determine the best location. Assume the following values. So location 1. Living standard. Living standard is also very important. For the location 1, we got excellent rank. Excellent means 10 points will be given. And weightage being 30. So excellent means 10 and weightage being 30. It's not only 10. You have to multiply with the weightage also. So 10 into 30, 300. Good means 6. Very good means 8. 6 into 10, 60. And very good means 8. 8 into 5, 40. And fair means 4. 4 into 15, 60. And very good 8. 8 into 10, 80. Poor only 2. 2 into 10, 20. And very good 8. 8 into 20, 160. Get me the total here. 720. Same way you can calculate for the location 2 and location 3. So 720 is this value. In case of location 2, you get 680, location 3, 620. Among the three, the best being 720. So you have to choose location 1, which is called weighted factor rating method. Weighted factor rating. Clear? And we have the center of gravity model. Already explained, no? Center of gravity model. Okay. Closer to all the resources is called center of gravity model. Okay. Now, we'll see an example here. Okay. So that you will be able to understand. Of course, this question is pretty rare in your examination, but anyhow, to understand, I have given this here. SSA Limited wants to open a furniture shop in Trichy, Tamil Nadu. I only constructed this to make you understand the center of gravity method. Okay. The coordinates of the locations and volume of customers are given in the following table. So, location, customers, volume and coordinates given here. Coordinates given here. Now, what you have to do is, this is otherwise named as V. You have to multiply V into X and V into Y. V into Y. Okay, 2 lakhs into 80. I may post this value in thousands. 200 into 40. 8,000. 200 into 110, 22,000. 100 into 42, 4,200. 105 into 100, 10,500. And here 150 into 50, 7,500. This question is not in your text, also not asked in the examination. Very rarely the theory question may be expected. Very rarely. Anyhow, I want to make you understand the calculations part, so I constructed the illustrations for your better understanding. So 120 into 150, 18,000 rupees. 250 into 45, the value being 11,250, and this is 25,000. Now the total value in this case being 30,950 and 75,500. Now you have to find out the x-axis. X coordinate is equal to summation of Vx by summation of V. Y will be equal to summation of Vy divided by summation of Y. First, understand the calculation. I will explain the part later on. No problem here. So, summation of Vx being 30,950 and summation of V being, come on, get me this value. Hope this is 700. So, I divide this by 700, then the value being 44.21. And here summation of Vy being 75,500. 75,500. Okay. Isn't it? So 75,500 divided by 700, then the value being 107.86. Is that okay? Now let me now explain. These formulae given directly, okay. If you read the text, no, you will not be able to understand. That's why I converted that into the illustration. Now I'm going to make this as a diagram to make you understand easily. Then you can go for reading the theory. You will be very easily understand the theory. Very rarely the theory may be asked in the examination. Right. See here. X-axis and Y-axis. X-axis is anywhere between 40 to 45. I'll start with the false baseline here, starting with 40, 42, 44, 46, 48, and goes on. And in Y, we start with 100, 104, 108, 112, 116, 120, and so on. Is that clear? Now, I'm going to plot this. What about the A's are 40, 110. 40, 110 could be here. This is location A. This is location A. B, 42, 105. This is location B. C, 50, 120. 50, 120. Okay. 50, 120 could be here. This is location C. And D, 45, 100. This is D. Okay. Now, which location to be chosen, sir? The location to be chosen in this case being X should be 44.21 and Y should be 107. 107. Then it should be anywhere between this place. This is the most optimum one. The most optimum is this one, means you can choose B. We have 4 locations, then which is better location? B is the better location. That's very closer to the center of gravity. The exact location is here, but you don't have this space to construct your facilities. What can you do? Nearby you just see. This is my first illustration I gave here. Okay, you convert this into a graph, and this is x-axis, this y-axis, and these are the coordinates, where D may be the best one. This D coordinates may be calculated by this way. So here we have taken one more point, which is nothing but what? Volume, the customer's volume also. Okay, in this case we have the volume only 200, and in B we have only 100, in C we have 150, here we have 250. So after considering not only the exact place, we have to consider the volume it handles. Based on that, the center point will be this one, and you can choose any place near to that dot. Any place near to the dot. Purpose. Optimizes the facility location. What? Minimize the transportation cost. So if you choose the center point, all the resources may be closer. Raw material also closer and finished goods also closer. While manufacturing, the raw material can be purchased from very nearby, and finished goods also be saleable to the nearby without much of transportation costs. Right. Focus, the main focus, determines the central point between the supply and demand location. So center point. And key factors, coordinates of supply and demand matters. Quantities and volumes also be incorporated. Not only coordinates, but we have to consider the quantities and volumes also. Steps, calculate weighted average of X and Y coordinates, and divide this by locations. The result is the center of gravity. Calculated weighted average of X and Y. Here we have got the value being 44 and 107. 44 and 107. This calculation of weighted average of X and Y coordinates is nothing but total value divided by volume. That's how we get this value. And this particular coordinates will be the center of gravity. Application, commonly used for the warehouse and distribution center selection. So usually this will be used for warehouse construction as well as distribution center. So GeoMart, if you order, then in matter of half an hour, 10 to 30 minutes, you will get the product delivered today, currently. So whatever the goods you order, no, within 10 to 30 minutes it should be delivered, means it should be center of the place. The actually Geo Smart Bazaar may be 15 or 20 kilometers outskirts, but they may have the distribution center here, so that once the order is confirmed, immediately sold. Okay. Hope you will be now able to understand the center of gravity model. Center of gravity model. Clear? Now, the next one is all about break-even analysis. Break-even analysis. This is the most important models, and you can expect this one only in your examination. Of course, break-even point and indifference point, I am not going to teach you here, but I am going to solve the illustration directly, because the conceptual background was already solved under marginal costing chapter. Finish your marginal costing and then come here, especially the indifference point. So the rules I taught you in the indifference point is what? Indifference point is equal to difference in fixed cost divided by difference in variable cost or contribution. That's what about the indifference point between the two options given. Is that okay? And fixed cost is high and variable cost per unit low, then this will be suitable for what sort of demand? High demand. If the fixed cost is higher, this will be suitable for the high demand case. If the fixed cost is low, variable cost per unit is high, then this is suitable for what? Low demand scenario. Low demand scenario. Same we have already discussed in the marginal cost. Let's now try to solve this illustration. A company is planning to undertake the productions of medical testing equipment, has to decide on the location of the plant. Three locations are being considered, namely A, B and C. So we have three locations, A, B and C. The fixed cost of the three locations to be 300 lakhs, 500 lakhs, 250 lakhs. The variable cost, okay, variable cost per unit, 3,000, 2,000 and 3,500. The average sales price of the equipment 7,000 rupees. You no need to consider the sales price. By considering the sales price also, you will be getting the same answer. So you no need to worry about that sales price. Already we discussed that no. In case of indifference point, difference in variable fixed cost divided by difference in variable cost, or difference in fixed cost divided by difference in contribution, also you will get the same answer. Contribution is equal to the profit, no? So for this only you need the sales minus variable cost. Either you can take the contribution or variable cost, you will get the final answer be the same. So never bother about the sales revenue here unless specifically stated. Now calculate the total cost of the following range of the product. Come on, tell me. Okay, tell me. What about the total cost? For A, B, C. A, B, C. For 5,000 units, 10,000 units, 15,000 units, 25,000 units. 20,000 units and 25,000 units. Is that okay? How do you calculate the total cost? Total cost is equal to fixed cost plus variable cost per unit into number of units. This will be similar to what? This forecasting. Fitting this straight line, you know, which is nothing but Y is equal to A plus BX. X is equal to Q, B is variable cost per unit, A is equal to fixed cost like. So the same formula is represented this way. Clear? Come on, tell me. For A, fixed cost 300 lakhs, 5,000 into 3,000 rupees, 150 lakhs. 150 plus 300, 450 lakhs. Am I right? 450 lakhs. Fixed cost remains same for every 5,000 units at the rate of 3,000. Additional variable cost to be 150 lakhs. Am I right? So you just hereafter, from increasing from 5,000 to 10,000, we need to incur only the variable cost. The variable cost for 5,000 units being 150 lakhs. So 450 plus 150 is 600 lakhs, 750 lakhs, 900 lakhs, 1,050 lakhs. 1,050 lakhs. In case of B, 500 lakhs is the fixed cost, 2,000 will be the variable cost. 2,000 into 5,000, 100 lakhs. So 500 plus 100 lakhs, 600 lakhs. Thereafter, for every increase of 5,000 units, for every unit 2,000. So 5,000 into 2,000, 100 lakhs will be increasing. 600, 700 lakhs, 800 lakhs, 900 lakhs and 1,000 lakhs. The last one C, 250 and 3,500 per unit. 3,500 into 5,000, I think 175 lakhs. 250 plus 175 lakhs being 425 lakhs. Am I right? Are you getting this? Come on. Thereafter, for every 5,000, 175 lakhs will be increasing. So 425 plus 175, 600 lakhs, 775, 950 and 1,125 lakhs. Clear? Now tell me, at 10,000, A and B are merging. At 20,000, A and B is same. Is that clear? Clear? So this is what about the indifference point between A and C. This is the indifference point between A and B. A and B. Indifference point means if your demand being 10,000 units, choosing A or C, you will be getting the same cost. As the cost is same, sales revenue being 7,000 per unit, revenue also being same. At 20,000 units, 900, 900. Whether you go for A or B, you will be getting the same cost. Now, if your sales is less than 10,000, what happens? 5,000. Which is chosen? C is chosen. Okay. If you go beyond 25,000, which is the cheapest one? B is chosen. So, if the sales is less than 10,000 units, C is chosen. Exactly 10,000 A or C is chosen. Exactly 20,000 A or B is chosen. If the demand is more than that, B is chosen. But if it is anywhere between 10,000 to 20,000 rupees, then among the three, the least being what? A. Here A is chosen. You can write here from 0 to 9999, A is chosen. Exactly 10,000, it is indifference point. Whether you choose A or C, you will get the same cost. From 10,001 to up to earlier to this one, 19,999, you have to choose A. And 20,000, so this one, first one is C, right? This one is C, sorry. This one is C, isn't it? This one being the C. 20,000 and more, exactly 20,000, whether you choose A or B, you will get the same cost. If it is more than 20,000, 20,001 plus, then automatically B is chosen. Okay, now based on that, select here the best location if the sales volume expected being 18,000. Expected being 18,000 means you have to choose which location. A is a good location for you. Even you can draw this in a graph. So I have given the graph here. You can see this graph here. Okay, this is the graph. You can plot here. See the graph. This one is A. A this way. And green color is B. This one is B. And violet color is C. You see the lower value. This is the point where here violet is lowest cost. And from here to here, red is lowest. From here to here, green is lowest. Am I right? This will be the indifference point between blue and or violet and maroon. What is that? A and C. Indifference point between A and C. And here green and red. Indifference point between A and B. So violet means what is that? C. C is chosen up to this point. And this is the indifference point. Thereafter, green. Green is what? B is chosen. Between this range, what will be chosen? The red or violet, which is B. Am I right? Sorry, A. Here C, here A, here B. What we have already found out here is the same. Am I right? Are you getting this? Hope you will be now able to understand. C up to this point, this one, exactly 10,000. A and C is merging. Thereafter, from here to here, A is better. Exactly 10,000. A and B will be equal. This point. Thereafter, green. Green is B. B is better. Right? So we got the answer. Anyhow, already we studied way in marginal costing. Higher the fixed cost and lower the variable cost per unit will be suitable for the high demand. So here, this is the highest one. B will be suitable for highest demand, and C will be suitable for lowest demand, and A is in between, so it is suitable for medium demand, mid range. The same for the low, C is better, for high, B is better, for the mid range, A is better. Clear? Apart from that, we have to apply the formula also. What is the formula? We learned that also in the marginal costing. The formula is nothing but indifference point between, we try to find out the A and C. Difference in fixed cost divided by difference in variable cost per unit. Difference in fixed cost between A and C. Come on. 300 lakhs and 250 lakhs, 50 lakhs in numerator. Difference in variable cost being 3000 and 3500, 500 being the variable cost. Come on, get the value. You get the 10,000 units here. Clear? Similarly, you can calculate the indifference point between A and B also. You'll get 20,000 rupees being the answer. Okay. Let's try that one. So, indifference point between A and B. The difference between A and B is fixed cost being 300, 500, 200 lakhs in numerator. In denominator, the difference between these two, 1000. Then 20,000 you get. Sir, will I be able to get the indifference point between B and C, sir? Try indifference point between B and C. The fixed cost between B and C being 500 and 250, the difference being 250. $250 lakhs divided by the difference between these two variable cost being 1,500. What's the ultimate value? So if you ask me, why don't we consider this, sir? You can go and see the graph so that you will be able to understand. This is higher than the R, where this is nothing but indifference point. Anywhere between these two, maybe 16,667. This is the indifference point between B and C. But we don't have any use because of the lowest cost falls under the red color, which is nothing but A. A being cheaper, the indifference point between B and C is immaterial for me. Clear? So in your examination, most probably you may be apply the formula to get the answer. Rarely they may ask you to draw the graph also. I have drawn the graph also for your better understanding. One more illustration we have to discuss. With that, the location topic will be over. Then we move on to the level. So we'll continue the rest in the next class. Come on, make a note of it.